Most people think generative design using AI means a computer magically invents parts on its own, but the truth is far more grounded. Generative design is about letting algorithms explore design options within rules defined by engineers. Long before AI tools existed, engineers already optimized designs manually. Generative design simply automates and massively scales that exploration. To see this clearly, imagine a simple everyday situation where you arrange furniture in a small room. You know the room size, where doors and windows are, and what must fit inside. You try different layouts until you find the best balance between space, comfort, and movement. Without realizing it, you've just done generative design, defining constraints and exploring options to find the best solution. What's actually happening here is simple. The engineer defines goals and constraints, such as load limits, material, weight, manufacturing method, and safety factors. The algorithm then generates thousands of design variations, evaluates them using physics-based simulations, and filters out weak or inefficient options. The result isn't one perfect design. It's a set of high-performing candidates for the engineer to choose from. Now imagine a real engineering case, designing a lightweight mounting bracket for an aircraft or electric vehicle. Traditionally, an engineer would sketch a solid-looking bracket, simulate it, remove material, and repeat this process many times. With generative design, the engineer instead specifies the mounting points, loads, safety factor, and manufacturing method. The AI then generates dozens or hundreds of organic-looking geometries, removing material only where it isn't structurally needed. Each option is simulated automatically. The engineer reviews the results, selects the best-performing design, and adjusts it for manufacturability. The algorithm didn't design the part. It explored the design space faster than any human could. This same logic is already used in industry. Aerospace companies reduce weight while maintaining strength, automotive engineers optimize brackets and chassis components, and manufacturers combine generative design with 3D printing to produce parts that were previously impossible to make. The payoff is lower weight, better performance, and faster design cycles, not artistic shapes for their own sake. Modern generative design tools were popularized through platforms like Autodesk, which integrated AI-driven optimization directly into CAD and simulation workflows. This made generative design accessible to practicing engineers rather than just researchers. In practice, generative design follows a clear workflow: design intent, constraints and loads, algorithmic generation, simulation filtering, engineer selection, manufacturing validation. The engineer remains the decision maker. Generative design simply expands what's possible to consider. Now that you understand the intuition behind AI-driven generative design, the next natural step is to explore digital twins and real-time optimization, where designs don't just get optimized once. They evolve continuously as systems operate. And that's exactly what we'll break down in the next episode.